The documentation provided presents a world of geometric perfection, a world where, if you treat the vector field with the right parity, everything cancels out nicely to zero. It offers an elegant promise that by simply identifying whether a power is even or odd, we can tame the chaotic flow of a force field into a predictable, binary outcome. However, if we look at this through a more cynical, real-world lens, we find that the page is selling us an illusion of equilibrium. Here is a narrative counter-perspective to the findings on that page. The myth of the perfectly balanced field. The divergence theorem, as described in the documentation, is a beautiful construct, but it is ultimately a hostage of its own symmetry. The page prides itself on the discovery that when the exponent is even, the field exhibits symmetric inward and outward flow that cancels out to zero. The illusion of cancellation. The documentation treats this cancellation as a fundamental truth. But let's be honest, in any physical system, cancellation is rarely a state of rest, it is a state of high tension. By claiming the net flow is zero, the model ignores the reality of the struggle occurring inside that sphere. Just because the ledger balances at the end of the day doesn't mean the forces cease to exist. It means we have chosen to look at the system from a perspective that conveniently hides the friction, the turbulence, and the actual energy transfer occurring at every single point on that surface. The fragility of the origin. The entire argument hinges on a precarious assumption that the sphere is centered exactly at the origin. The documentation admits that when you shift the sphere, the symmetry breaks. This is the hidden truth the page brushes over. The moment you move that sphere even a fraction of a millimeter away from the perfect center, the beautiful balance is destroyed. The zero result vanishes, replaced by a messy, non-zero flux that the page dismisses as a simple polynomial function of position. The bias of the model. The page relies heavily on perfect spherical geometries and clean power law fields. But the real world is rarely made of spheres centered on an origin of zero. It is made of irregular boundaries, shifting fields, and noise. By focusing so intently on the cases where the math works out to a neat, clean zero, the documentation steers the reader away from the more important, messy questions. What happens when the field is not a perfect power law? How do we account for the near misses, where the symmetry is almost there but not quite? Is the zero result actually useful, or is it just a mathematical artifact that distracts us from the underlying energy density? The verdict. The page offers a great roadmap for a fantasy land where forces exist in perfect, predictable harmony. It is an excellent guide for learning how to manipulate the math to reach that state of zero. But if you are looking for how the world actually behaves, where symmetries are constantly being broken and forces rarely cancel out so conveniently, this documentation is a map of the calm eye of the storm, intentionally ignoring the chaos swirling everywhere else.